In this video, we will learn about matrices in MATLAB. So a matrix is usually starts with a square brackets and ends with the square brackets, and it has columns and rows. So this is mainly how it looked like. So like this is matrix A. So you can see these. It has 3 rows and 3 columns. And usually we identify the row with the number of rows is listed first, like this is 3 by 3. So the first number is the number of rows, and the second number is the number of columns. To create a matrix, we have to put the elements in the row with space or commas between them, and then every time when you need to move to the column, then you put a semicolon. So you can see here, so this is the first 3 elements are the rows, so 2, 4, 6 with the spaces between them. Then you put a semicolon, that means that you are moving to the second row. Then you start listing the elements of the second column, 8, 10, and 12. Then you put a semicolons, means you are going to a third row, and then you list the elements of the third row with spaces between them. And similar to vectors, we use each element in the matrix has an address, and the address consists of the row and the column. Like this, if you look at this element here, it's in row 1, and usually the first one represents the row, and the second number represents the column. So this is in row 1 and column 3, and that's very important to remember, because later sometimes we need to call certain elements. We could call certain column or certain row or certain element in the column. So if we look at this example here, like let's say if I want to call just this element, like the 4, I could say, so this is A, 1, and 2. So this is just mainly element in row 1 and column 2. We could also call the whole column or the whole row, like if you look at this, like let's say A2, so this means the second row, and when you put a semicolons means all columns. So that's mean all columns. So you have to list all of them. If you reverse that, let's say if I put a colon and 2, then this means all rows and for the second column. So that will be that. The answer will be 4, 10, 16. We could pick a few elements, like in this example here. So this is all rows for column 1 and 1 and 2. So that's mainly you get these 2 columns here, and we skip the last one because we put if it's the column here means all rows. Let's demonstrate with MATLAB. So as you can see here, to create a matrix, we start with putting each row, the elements of each row separated with the space or comma. So this is the first row, the second row, the third row, and the rows are separated by semicolons. So the elements within the row are separated with space, but to separate a row from another row, you put a semicolon. So let's run it. So you can see so this is a matrix, and the size of that matrix, we'll see this later. So the size, it has three, we call it 3 times 5, means 3 rows and 5 columns. So this is column 1, column 2, column 3, column 4, and column 5. And I could ask you to only pick one element in the matrix. So you have to know the address for each of them. So the address for the 8 here, it's 2, which means in the second row, and 2 and 4, which means in the fourth column. We could append or combine matrices, but to do that, we could either add a matrix to the right of the original or below the original matrix, like in this case. But to add it to the right, the number of columns should be the same. To add it below that matrix, the number of columns should be the same. So if you look at M1, it has 2 rows and 3 columns, and M2 has also 2 rows and 3 columns. So then we could, since they have the same number of rows, which is 2 rows, we could add M2 to the right of M1, so we can combine the two together. So let's run it and see. So you can see this is M1, 2 rows, M2 has 2 rows, then M3 just appending M2 to the right of M1, so that now you get a bigger matrix there. So it's critical that you remember that to add them next to each other, or to add the second matrix to the right of the original, they should have the same number of rows, otherwise it will not work. So let's look at another example now if we want to append the matrix below the original one. So now to do it below, then we need to put a semicolons, means we need it to be M1 to be below, M2 to be below M1. And in this case, it will work because each of them has 3 columns. So let's run it and see. And you can see this is M1 has 3 columns, M2 has 3 columns, then M3, just combining the two together, and it worked because each of them has 3 columns. And we need to learn about index. So let's see here. If we want to look for which element, this means the element in the 3rd row and 2nd column. So let's see the 3rd row. So this is the 1st row, 2nd row, 3rd row, and 2nd column. So that should give us an answer of 6. So this is looking for this element. It's easier to see it when it's in a matrix form. So the answer is 6. So you can see it's here. So this is 3rd row and 2nd column. So this is this 6, not this one. How about this one? So this one, it says 2nd row. We need the 2nd row with all columns. So this mainly saying we need the answer should be all of the 2nd row, because with all columns. Let's run it. And that's what we got. So 3, 4, 6, 8, 9. How about if you put a colon, then 2? So with colon and 2, this means all rows but the 2nd column. I think, yeah, this will be easier to see it if in a matrix form. So we need all rows in the 2nd column. So we need the 2, the 4, and the 6. So 2, 4, and 6. So this is maybe all rows in the 2nd column. We could pick a range of elements, like in this case. So what does that mean here? So we need 2nd and 3rd element, 2nd and 3rd. So this is 2nd and 3rd rows, and we only need the columns 2 and 4 from them. So again, let's so if you look, this is the matrix. We need the 2nd and 3rd row. So these are 2nd and 3rd. We only go to this from 2 to 4, 2, 3, 4. So this is mainly what we are looking at for. And if you look, so this part of the matrix, similar to vectors, we could do mathematical operations in the elements. So like this is stepwise for each element. Like if you put m plus 2, that 2 will be added to every element in the matrix. So let's run it. So then the first one will be 3, 5, and so if you compare them, So the 1 became 3, the 2 is 4. So every element was gained 2 to become the new matrix there. We could do the same thing with other operations. If you look at subtraction, it's the same concept. So 1 minus 2, then we have minus 1, then 2 minus 2 is 0, 3 minus 2 is 1. So just stepwise. So every element is 2 is subtracted from every element in the matrix. And then for the multiplication, if we multiply it by 2, let's see if we run it. Some operations, they require you to put the steps, so to put the dot. So this one worked without the dot. So 1 times 2 is 2, 2 times 2 is 4, so it worked fine here. And let's see division. So the matrix divided by 2. So that one, let's run it and see what you get here. So it worked like if you put matrix divide by 2, every element is divided by 2 of the matrix. But how about now if we try to do the opposite, like 2 divided by the matrix? It will not work without putting that dot there. So if you try to divide 2 by the matrix, it will not work stepwise if you forget to put that dot there. So let's run it now. So you can see it worked. So 1 divided by 2 is so 2 divided by 1 is 2. 2 divided by 2 is 1, and so on. So if you forget to put that dot, it will give you an error message. So you can see it will give you that you need to maybe include that dot to make it stepwise operation. The same thing applied to exponents. So like matrix to the exponent to squared. So we have to put, if you don't put that, you get error message. With that dot, you get the answer, like 1 squared is 1, 2 squared is 4, 3 squared is 9. So it's working. And if you try to remove that, you will get an error message. So let's run it again. So you can see it asks you to put the dot to fix the issue. We could apply that functions like the same way to we did it with vectors, but we will get the answers different. So let's see how it looked like if you run the square root of m. So you can see it applied the square root to every element of them. Other functions, they will be applied to every column of that. We will cover that in different video. And that's kind of what I told you about before, like the size of the matrix is usually, it should give you the number of rows and the number of columns. So that's then the first number is the rows. So we have 3 rows, and the second number is for the columns, which is 5 columns. We could, if we make a mistake, we could replace one element so we don't have to retype the whole thing. So like this case, if I want to replace the element in the second row and third column, so that's this 6, we need to replace it with 5. So let's run it, and you can see the 6 was replaced with 5. We could delete, but here not like vectors, because we have to have each column, they have to have the same number of rows, and the rows should have the same number of columns. So we could delete the whole column or the whole row. So like this case here, we need this is row 2. We need to eliminate when you put empty square brackets, means you delete the whole row 2. The second row is gone. If we do this, this means we need to delete this. This is the second column, and for all rows. So mainly we'll delete the 2 from the first row, the 4 from the second row, and the 6 from the second row is gone. So go from 1 all to 3, like 1 to 3, 2 is gone, the 4 is gone, and the other 6. Another applications for matrix is to solve linear equations, and that's very important. Like let's say if you have a set of equations, when we're doing that, we put the coefficients of the variables like a into matrix. Like this is the, just extract the numbers there. So 1, 3, and 11. So these are the columns, and these will be the rows. So we have 3 rows, and we will call this matrix M. So this is, you can see it. So 1, 2, 3. So this is the first row. Then the second row 3, 4, 6, and the third row 11, 6, 2. And then we make another matrix for the after to the right of the right is a column vector. So you can see we put semicolons there. And to solve for the values of A, B, C, we just use the X, like matrix that the inverse divide over B, so that if you run it, this will give you the solve the 3 problems for you and find the value for A, B. So let's run it here, and you can see these are the values. So that's x1, which is the A, x2, which is the B, x3, which is the C. And you could give them different names like x1, x2, and x3. And we are going to use this in one of the labs, so you have to learn how to do this too. Okay.